Welcome to myprojectbazaar.com. Our product title is Control and Performance of a Transformerless Cascade PWM STATCOM with the store. Let us see about the abstract of our product. In this proposed implementation design is a 3-phase transformerless cascade pulse width modulation static compensator. Static compensator is known as static synchronous compensator, intended for installation on industrial and utility for industrial power distribution system. It proposes a control algorithm that devotes itself not only to meeting the demand of reactive power but also to voltage balancing of multiple galvanically isolated and floating DC capacitors. The control algorithm based on the base shift carrier modulation strategy is prominent in having on restriction on the cascade number. Cascade STATCOMs can be classified into staircase modulation and pulse width modulation in terms of voltage control. In this proposed design is based on PWM. The AC voltage of the STATCOM is almost sinusoidal, so that it requires no harmonic filter. Each converter is equipped with a capacitor and a voltage sensor on the DC side, which are electrically isolated from each other. The STATCOM has the capability of self-starting and voltage balancing without any external power supply or equipment. Thus, results prove the stable operating performance of the proposed method in steady state and transient state. Next, we see about the flow diagram of our process. In this flow diagram, the source is a AC supply and also that source is a 3-phase AC source. So, deliver of the 3-phase AC source is fed into the 3-phase load through a passive elements and also the STATCOM devices. So here the passive elements using the inductors. After that we using a one breaker. In that breaker output is connected to the clustering unit. In the clustering unit having 3 bases, each base having a inverting circuit. So here this is a PWM STATCOM unit. In that unit the input DC source is fed into a inverter, single base inverter circuit. So in the inverter circuit is connected in 3 parts. So that 3 parts is connected with a cascaded. So the overall process is called cascaded PWM STATCOM. So in each base that is connected in the similar manner. So finally that output of the 3 cluster unit is connected to the 3-base load. In the 3-base load may be a resistive, capacitive or inductive load, and also in the 3-base source input source is a grid. Generally the grid source is connected to the load, that is a consumer, and also using the STATCOM the power factor will be maintained using of the various kinds of loads. Next we see about the running process of our product. In this proposed implementation is run in MATLAB simulating environment. First open the MATLAB window and create a new model file. After opening the new model file, we are arranging the elements as per the circuit diagram from the simulating library browser. In the simulating library browser, 2 major blocks is used. One is the sim power system block and another one is the commonly used block. From that blocks we getting the element from to the main module file. After that we are arranging that elements as per the circuit diagram. After that we get the output from the scope. The scope is getting from the commonly used block, then connected to the corresponding output area. Then click the run symbol icon, then the output will be displayed. First one is the grid side voltage and current waveform, and next one is the output voltage and current is after connecting the passive elements, and next one is the UV clusters voltage waveform, and that range is 150 volt. And next one is the output of the STATCOM PWM STATCOM output. First one is the inverter voltage waveform, second one is the converter voltage current waveform. So those voltage and current is injected into the main source. Then this is the single base source, so the voltage and current waveform is a single base only, and this is a final output 3 base voltage and current waveform. So from this waveform is connected, all 3 clusters is connected together to the load, and this is the load flow output waveform. So here we changing the frequency and base power, the values, corresponding values will change. Thank you for watching this video.